Unacademy. In this video, we are going to see the next type of classification of drugs, that is antimicrobial drugs. So that is third type, students, we are going to see. In next last video, we have seen the analgesic and tranquilizer. In this video, we are going to see the antimicrobial drugs. Antimicrobial drugs. Now, in this video, we are going to see the antimicrobial drugs. Now, sometimes they ask in examination, what is the antimicrobial drugs? So, definition, students, you have to write like this: the drug used to kill or stop the growth of microorganism. Students, you all know algae, fungi and bacteria. These are the microorganisms. That types of drug we called as, that is called as antimicrobial drugs. That drugs which we are taking for that to kill or stop the growth of the microorganism are called as antimicrobial drugs. Now, students, it is classified antimicrobial drugs. Antimicrobial drugs is further classified into three categories. First category, students, we are writing small a, that is antibiotic. All antibiotic drugs know it is also coming in antimicrobial drugs. Antibiotics. Second, students, we are writing antiseptic. Antiseptics, you are knowing, students. Now we are writing small b. And third one, that is last one, is disinfectant. We are applying on non-living thing. Disinfectants. So these antimicrobial drugs is further classified into antibiotics, antiseptics and disinfectants. Now, students, we are going to see the antibiotics. About antibiotics. What is the antibiotic, students? Antibiotics. In examination, sometimes they are asking definition of antibiotic. What is the definition, students? This definition, it is the drug. It is a antibiotic is also called as a drug which is derived. We are obtaining this drug from living matter. These substances, now, students, we are getting from living matter. Living matter, students, that is also called as from microorganism. These substances we are getting from microorganism, and this, after getting this substance, we are using to kill or prevent the growth of other microorganism. To kill the other microorganism or prevent the growth of other microorganism. So this is the definition of the antibiotic, students. Very important it is. Now, when you comes to the example, students, first example, students, we will see that example is antibiotic, students, which we are using, that is salvarsan, students. That what is the molecular formula? C12S2012 arsenic 2, and there will be 2 oxygen. This is the molecular formula of salvarsan. Now, sometimes they are asking, write down the structure, students. We will write down the structure also. Structure, students, how will write? Structure of salvarsan. Now, students, as you know, the molecular formula is what? C12S12 arsenic. How many arsenic molecule? 2 molecules. And oxygen, how much, students? 2. So how you are going to write it, students? First, students, you just see in molecular formula there is 12 carbons. That means it has 2 benzene ring. So this way you have to make the benzene ring. So one benzene ring contains how many carbon, students? It contains 6 carbons. 6 plus 6, 12. Now, in between your students, these 2 benzene rings is attached by arsenic. Arsenic, students, you know, it is trivalent. So arsenic double bond, and arsenic with benzene will be single bond. Now, opposite to arsenic, students, you have to put the hydroxyl group here. Opposite to arsenic, we are going to put the hydroxyl. Now, students, between arsenic and hydroxyl, here the things we are going to put the ammonia. that is amines we call as NH2. This side also NH2, So this is the structure of the solution. Sometimes in examination they are asking write down the structure of this antibiotic. This is the first example, students. Second examples we can take azodie, which is yellow in color, students. The formula is, students, molecular formula C12. Hydrogen atom will be 10, nitrogen atom 2, nitrogen atom 1, oxygen. So this is the structure of azodie, students. Here also, students, C12, that means there will be 2 benzene ring. So you make the benzene ring like this. These 2 benzene ring, because the written word is azo, that means these 2 benzene ring is joined by nitrogen. That is why it is called as azo. So this azodie. Now, students, opposite to this nitrogen, you have to put what, students? You have to put hydroxyl. So this is the structure of azodie, students. Very important antibiotics. Now third antibiotics we are going to see, students, that is called as protonsil. Third antibiotics name is, students, protonsil. What is the formula, students? Formula of protonsil C12 S13. There is 5 nitrogen, students, N5. There is 2 oxygen atom and 1 sulfur. This is very important, students. This is present in our body. Now, students, if you write down the, because here nitrogen, here is C12, that means there here also we have 2 benzene ring. C2, 1 benzene ring contain how many carbon, students? 12 carbon. So 12 carbon, that means you have to make 2 benzene ring. Now here you have to, these 2 benzene ring is joined by nitrogen molecules. You have to write. Now be opposite to this, you have to write sulfamide, SO2, NH2. Opposite to the bonding, students, you have to write amines. You have to put the amine group. This side also amine, because there is total how many nitrogen? 5 nitrogen. So 1 total, when you count number of nitrogen, 1 2 3 4 5 nitrogen, so N5, and 2 oxygens. From here you can get 2 oxygen. Only 1 sulfur is there, students. That is why I have written only 1 sulfur. Now, students, what happens when you, in our body, students, it is going to form the sulfur drugs. This bond will break and it will form the this type of drug, SO2, NH2, and here it will form the NH2, that is amine. This is the sulfur. We also call it, students, sulfur drugs. They are very important, students. They kill the microorganism. Now, students, we will see the next type of, that is fourth example is sulfur pyrimidine. Fourth drug name is, students, sulfur pyridine. Sulfur pyridine is also antibiotic, students. Sulfur pyridine structure we will write. Sulfur, because it contains sulfur, that is why it is called as sulfur, and there is a pyridine. Pyridine ring is also there, students, that is why it is called as sulfur pyridine. When you write down the molecular formula, carbon 11 carbon, hydrogen 11, nitrogen 3 nitrogen, and 2 oxygen and 1 sulfur. Now we will write the structure, students, this sulfur pyrimidine. Now because you see 11 carbon is how much? 11. So one will carry benzene ring, other will has pyrimidine ring, students. Here will be the nitrogen. This is the pyrimidine, and this is the benzene ring, students. Now because it is sulfur drug, so here sulfur dioxide is connected to the amines group. Here is also NH2 group. So this is the, students, sulfur. This is the structure of the sulfur drugs. Now, students, we have already seen antibiotics. These are the special type of antibiotic. Now antibiotics, students, further classified antibiotics depending upon the action, whether this antibiotic on the basis of action on bacteria. It is classified into 2 categories. First one we call it, students, broad spectrum antibiotics. Broad spectrum we call as antibiotic. Second type, students, antibiotic is also classified in narrow spectrum antibiotic, students. Now, students, here, students, you can write ampicillin example, amoxicillin. That means they will work on positive and negative, both bacteria they kill. That is why it is called as broad spectrum. Here students, when you see the example, students, penicillin students, here students, it will kill either positive or negative bacteria. That is why it is called as narrow spectrum antibiotic students. So depending upon the action on bacteria, it is classified into two categories. Now students, antibiotics is also classified. Antibiotics students, it has been also classified into two categories students. First one is whether it will kill the bacteria or it will stop. Depending upon the whether it is killing bacteria, then it is called as bactericidal. It is called as bactericidal. If it is stop the growth of the bacteria, then it is called as bacteriostatic. We call as that type of drugs which we are taking. That drug is name will be static drugs. That means here it is killing bacteria, and bactericidal kills the bacteria. Here students, it inhibits the growth of bacteria. Inhibit the growth of bacteria. Now students, when you see the example students, your example is afloxacin. Afloxacin is a drug which kills the bacteria. One more example students, penicillin. Penicillin is also a drug which kills the bacteria. Aminoglycosides. This will also kill the bacteria. Here students, when you see the example students, first one is tetracycline. It will stop the growth of the bacteria. Tetracycline drug will stop the growth of the bacteria. Erythromycin will also stop the growth of the bacteria. Suppose this drug chloramphenicol, it will also stop the growth of the bacteria. These are the basis of the action on bacteria. It is classified into two categories. Now students, we are going to see the structure of some bactericidal and bacteriostatics. First students, we will see the structure of penicillin. Structure of penicillin. That is, it is also called as students bactericidal. Students, what is the molecular formula? Alkyl group is connected to the C9H11, 2 nitrogen, 4 oxygen, and students 1 sulfur. This is the molecular formula of penicillin. Here R may be different. Now students, because it has only 1 sulfur, so we have to start from sulfur. It has 2 nitrogen, 1 nitrogen I am using here. And it has got 3 C9. So students, here we are writing, here will be 2 methyl group, and here because it has got oxygen, 4 oxygen, so we have to write this acid group will be present here. Now again students, it is connected here. One oxygen will be here, and the second nitrogen will be present here. It will combines with the carbonyl, and that carbonyl is combined with the alkyl group. So this is the structure of the penicillin. This is the structure of penicillin. So this way, that is why the structure is written as R, C9H11, N2, oxygen 4, sulfur. Yes. So this is the structure of the penicillin. Now students, we will write down the structure of chloramphenicol. Second students, second example, structure of chloramphenicol. Now what is the molecule? It is a bacteriostatic. It is bacteriostatic drug students. Formula, molecular formula students, the 11 carbon, 12 hydrogen, 2 chlorine, that is why it is a chloro. There is 2 nitrogen and 5 oxygen is there. This is the molecular formula students. So you have to start with the benzene ring students, because it also containing nitro group NO2, Now this is connected to the methyl alcohol. Now here two valencies is occupied by hydroxyl group. Other is hydrogen, other is ammonia with COCH Cl2. That is why it is chlorophenicol. Students, this is the structure of the bacteriostatic. Students, now students we will see the second part, that is antiseptic. Which antibiotic, antimicrobial drug we call as antiseptic? Antiseptics. Now students, antiseptic students, which is very drugs which are applied to the living tissue to kill the which kills the bacteria and to stop their growth in the wound are called antiseptics. This is the definition of antiseptic students. When you write, see the example. For example, chloroxylenol, biethanol. These are the antiseptic students. Terpineol, iodoform. They are the antiseptic students. Very important. You can apply on the body. Boric acid. Dilute phenol is also act as an antiseptic students. Dilute phenol. Hydrogen peroxide, it is also antiseptic students. So these are the antiseptic we can apply on the body students. Now we will see the structure of the some antiseptic students. First structure students. First one is chloroxylenol. When you see the formula students, molecular formula is C8H9, 1 chlorine, 1 oxygen. What will be the possible structure students? Here because C8 is there. So students, you have to write down the benzene ring which contains 6 carbon. Because here C4 here will be 2 methyl group, CS3. Now students, because it carrying 1 chlorine and here it is also carrying an hydroxyl. So this is the example of chloroxylenol. Students, second example is biethanol. When you see the structure students, what is the molecular formula? C12H6, 4 chlorine, 2 oxygen and 1 sulfur. This is the biethanol. Students, because the thionyl group means sulfur is there, so C12 means it will have 2 benzene ring. These 2 benzene rings is connected by sulfur students, which is divalent. Now because it is total how many chlorine is students? 4 chlorine. So you have to write 4 chlorine like this. 4 chlorine you have to put like this students. Now here you have 2 oxygen. Therefore, so here will be 1 hydroxyl group here students. Here will be also 1 hydroxyl. So this is the biethanol structure students. It is also antiseptic. Now students, we will see the structure of terpineol. Third structure students, we have terpineol. Formula students, C10H, hydrogen will be 18, 1 oxygen. So this is the terpineol. Students, because it contains 10 carbon, so there will be 1 benzene ring like this. Here will be carbon. Because 1 oxygen is there students, so you have to make 1 hydroxyl group. This is the terpineol. This is terpineol. This is also called as what? Terpineol. Formula students, when you write down the molecular formula, C10H18 and 1 oxygen is there. This is the structure of terpineol. Now students, we will see the last antibiotic, that is antimicrobial drug, is that is disinfectant. That we call as what? Disinfectants. Students, what is disinfectants? This is coming for 2 marks question. Students, it is a drug. It is applied to non-living thing. We are applying on the non-living objects to kill the microorganism, which are present on the object is called as disinfectant. That is what we call as disinfectant. Students, it is used in public health, sanitation, floor also we are applying to sterile the instrument, to kill the microorganisms which are present on the instrument. So we are applying on the instrument. That is why an instrument is a non-living things, etc. Example, students, we are passing chlorine gas, we are chlorinating water, we are sulfur dioxide gas, and concentrated phenol is also used for the disinfectant. So students, these are the example of the disinfectant. Okay students, if you like my video, please share it and subscribe it. Thank you very much.